Vertical asymptotes, domain holes. Specifically, this video is covering horizontal asymptotes. So we covered the 1 through 5 already. We've talked about vertical asymptotes, domains, holes, steps 1 through 5, factors, simplify, right in simplest terms, finding if something doesn't cross out on the denominator with x, that's going to get you a vertical asymptote, which is a restriction on your domain. If something does cross out with the simplifying process, then that's going to be the x value of a hole, which then you could plug into what's remaining to get the y value of the hole. So we've covered all of that. Now we have horizontal asymptotes. So that's going to be step number 6 that we're adding to our previous 5 steps. State any horizontal asymptotes. And horizontal asymptotes are actually probably the easiest one of all to do. And so I have a little bit of extra notes here for you. Horizontal asymptotes, there's 3 things that could happen. Now, a horizontal asymptote is let me stick with the pen. Options are determined by a comparison of the highest power of the numerator and denominator. What we mean by that is, take a look at our example here. It says 8x squared minus x plus 2. The highest power is x squared. The highest exponent is the highest power. And the highest power in the denominator here is x squared. So it's comparing the powers. So let me go back to reading that for you. So all you do for horizontal asymptote is you take a look at what's the largest exponent in the numerator, what's the largest exponent in the denominator. And then there's 3 things that could happen. One could be larger than the other, or they could be the same. We call it top-heavy if the numerator power is larger than the denominator. And if that is the case, the result is no horizontal asymptote. So if we look at these 3 examples we have here, which of these is top-heavy? Well, this is my top-heavy scenario. And I see that because my highest exponent of the numerator, or my highest power, is x squared, but the highest exponent or power of the denominator is that 1, which, that invisible 1. And so since there's a higher power on top than bottom, this is called a top-heavy scenario, and the result for your horizontal asymptote is none. So that's easy. Now, in the next video, in this particular case, we have something that's called a slant asymptote instead, but we'll get into that another day. All right, so that's top-heavy. It's top-heavy. Horizontal asymptote is none. Now, what if they're equal power? Like in my first example here, my exponent here is squared and my exponent here is squared. In the case of equal power, the result, the horizontal asymptote. Now, first of all, horizontal asymptote is a horizontal line. When we did vertical asymptotes, a vertical line is the equation x equals. A horizontal line, like horizontal asymptote, is going to be y equals. Not x equals, y equals for horizontal. The result is y equals, this is for equal power, the ratio of lead coefficients. So what that means, the lead coefficients are the coefficients of those highest power terms. So x squared is my highest power, its coefficient is 8. X squared is my highest power, its coefficient is 4. And so my horizontal asymptote is y equals 8 over 4, which I'm going to then simplify to be y equals 2. So in the case of equal power, you just take the coefficient of the top over the coefficient of the bottom of those highest power expressions, and that's your horizontal asymptote. And when we get to graphing, that's going to be a horizontal, dotted line crossing the x-axis crossing the y-axis at 2. All right, and the last scenario is bottom heavy. Bottom heavy, which you could probably guess, is when the bottom, the denominator, has the higher power. Like in this last example, my highest power of my numerator is 1. And the highest power of my denominator is 2. The bottom is larger. This is my bottom heavy scenario. And in a bottom heavy scenario, you do have a horizontal asymptote, but it's really simple. Anytime it's bottom heavy, the horizontal asymptote is y equals 0. So no worry about coefficients or anything else like that. The result is always y equals 0 in a bottom heavy scenario. And y equals 0 is the x-axis itself. Think about a horizontal line crossing 0. That's the x-axis. So there's three ways horizontal asymptotes can go. A top heavy scenario is none. A bottom heavy scenario is y equals 0. An equal power scenario is one where you actually have some numbers involved besides 0, and it's just the coefficients. The coefficient of the numerator over coefficient of the denominator of that highest power term. Now, going back to these steps 1 through 5, this requires us to factor, simplify, stuff like that. When we're comparing highest powers, it's to the original term. So notice that I did not factor anything like that, but usually we do at this point. So like if we were to do this problem from the start, I'm not going to, but I'll talk about it. I would factor the numerator, factor the denominator, state my domain, simplify, state any vertical asymptotes, state any holes and stuff like that. When I go to step 6, state any horizontal asymptotes, I need to go back to the original problem and use that as my comparison, not the simplified problem, the original problem. Okay, so you don't want to cross things out too much. You factor over here and simplify and stuff like that, but when you go with the horizontal asymptotes, which we don't do until step 6, you need to go back and look at the original pre-factored problem, and that's what you use to evaluate. And I don't know why, but my 2 got erased here. So like for this example, I'm not going to do this because this is where we're going to start off in class tomorrow. I want you to factor, state the domain, state the vertical asymptote, state any holes like you did yesterday. But then go back and look at the original problem and state any horizontal asymptotes with top heavy, bottom heavy, all those scenarios. Top heavy, none. Bottom heavy, y equals 0. Equal power, coefficients. That's it. See ya.